Power up. Welcome to Energypreneurs, where I bring to you the exciting new opportunities in solar power, battery, and electric cars. I'm your host, Sohel Hasni. I've been tracking and analyzing these technologies on LinkedIn and Twitter for more than 10 years. Now we meet on podcast. Okay, Emily, good morning, good evening.
Good evening for me. Good morning for you.
Yeah, it's been a while since we spoke, no? Almost more than a year.
I think so. Much has changed in the world and in our respective businesses, but all is well, at least for now.
Yeah. So last time we just spoke, you were one of my earlier podcast guests, and we spoke about nature's batteries, right?
That's right.
So give me an update. Where are you? What other exciting things you are doing these days?
Yeah, so we are still pursuing the vision and the mission that we have to take this natural battery in the waterways that are all around us and turn that into usable, cost-effective that's reliable around the clock water flows. And we are pursuing that goal and have been able to realize the fruit of that goal. And now more than just 5 sites in the US, but also now in multiple countries, interconnected, feeding clean local hydropower into the grid in New Zealand, as well as interconnecting as we speak our first system in South Africa as well. And so exciting for us to be expanding beyond borders with this new style of hydroelectric power, which is
New Zealand,
distributed.
South Africa. Yeah, New Zealand, South Africa. So you're starting from the Southern Hemisphere. So what's happening? Are you doing something in Australia as well?
Yes. We actually have built out a team in Australia that is very familiar and has a lot of local expertise with both distributed power generation, which is, of course, very, very common in Australia with the prolific rooftop solar in the country on the grid, and also has a deep knowledge of the waterways and water infrastructure in Australia. So as a reminder for those that perhaps didn't hear the first podcast that we did together or aren't familiar with Emrgy or me, we're building out systems that are distributed generation, just like rooftops or community solar, but utilizing water infrastructure, whether that's urbanized water infrastructure with water treatment facilities, whether it's industrial water infrastructure for effluent flows after industrial processes, or whether agricultural, which is our most common site for installation, cultural water infrastructure, that open channel water flow that brings water out to farmland. And so being able to take these resources and utilize them for not just power, but also, not just water, but power also, is where Emrgy focuses and brings value to our customers.
Yeah, the reason I asked about Australia is, of course, because last time we discussed the largest potential for micro-hydro will be in developing countries, distributed population. So I've never been to the Pacific, but the Pacific, all those small countries, that sounds like a really distributed, dispersed population. So Australia is a stepping stone to go there, right? So that would be the next step.
That's right. And actually, with our team based locally in Australia, we are evaluating the feasibility of a number of different projects across. We are speaking with and looking at sites with villages in Indonesia. We're looking at opportunities across the Philippines. We're seeing the opportunity and really, the deeper value of being able to access reliable energy within a distributed format. There is especially, with the growth in distributed solar, the access to power, does seem to be growing, but in terms of getting power that's reliably generating around the clock is something that without energy storage is very difficult to do with other distributed renewables. And that's where water becomes that natural battery, is that it does have potential to operate reliably all the time. And so being able to provide that to potentially to villages or areas that don't currently have another option is something seeing a lot of both interest and also potential in. We've been building our large and small around water forever, since the beginning of civilization, because that water provides us with both the transport, of course, the water and sanitation that we need, and using that same water for electricity is something that is very natural alignment.
Yeah, I mean, and then of course, we briefly discussed the other day is sort of if you go into high-tech agriculture, which is the drones that you need to fly and hydroponics, aeroponics, and all of those technologies, if you do indoors or vertical farming, you also need in remote areas electricity, right?
That's right. A lot of people, we recognize the things that our communities need to advance. We know that we need healthy food. We know that we need clean water. We know that we need education and access to good sanitation and medical supplies. But in this modern world, in the 21st century, those things don't exist without electricity seemingly anymore. Whereas back a century ago, you could develop different, of course, agricultural resources or could purify water through different means. Now, most all of our advanced technology requires electricity for operation. Being the catalyst, whether Emrgy is simply taking the electrons that we are able to take, from the movement of the water, convert those into electrons, whether we deliver the electrons directly into a home for lighting or whether we deliver them into a hydroponics or aquaponics facility. And the benefit of the system is fresh food or fresh produce, or whether we deliver it into, let's say, a hydrogen fueling station, and the result of that is clean fuels, or whether we're delivering that into a freezing facility or refrigeration facility for medical supplies or things like that. What we see energy being the catalyst for so many other drivers of community development, that the partnership aspect of what is growing tremendously. And so not just looking at pure power projects anymore, but opportunities to align with other advanced technologies or companies that are providing services that are dependent on electricity in a rural environment.
Yeah. It could be an electric fishing boat or
Absolutely.
electric bicycle or electric truck for carrying goods. I mean, flying drones, flying aeroplanes. I mean, once you have the electrons, it's sort of everything. And if you are able to bring it to where people live or where it will be consumed, we discussed last time, you don't need all these large distribution and transmission lines.
Yes,
Fantastic.
yes. We believe the future of energy is distributed. And regardless of the many different formats of how we generate it, whether it's from the wind or from the sun or from the water, that we need to be generating power where the power is needed, or as close to that as possible, so that we can ultimately have more cost-effective, reliable power when we're using it in a more sustainable, localized format. And that's one of the major areas of technical innovation as well that Emrgy has been focused on in recent months. Is we have, as some of you may recall that may have listened, we have a modular format of hydropower that requires no construction whatsoever. And essentially we bring the whole system out, and it's a drop-in, plug-and-play hydroelectric system for open channel water infrastructure. That module itself is unique. It is a number of hardware focused patents that we have filed in many different regions of the world. But generally speaking, the concept, the physics concept of taking a rotary machine, placing it in a fluid, whether that's air or water, and taking that fluid into mechanical energy of torque and speed around a shaft, then to electrical energy, is something that, of course, is fairly and broadly well known. How we take that module and connect it to those many other systems that we just talked about, whether it's an electric charging station or whether it is even an electric tractor, out on the farm, or whether it is other types of systems that are delivering value both to rural or urban environments. Emrgy's focused very strongly on that connection piece. Traditionally, up until about 5 years ago, even, the industry was marked by customized equipment, custom power electronics, things that would need to be certified again and again when you move from region to region or utility to utility. And one of the beauties that we've seen in the solar industry is broad sort of global standardization in power electronics and in the ability to have them widely accepted across continents and across utility requirements. And while hydropower has necessarily seen a similar emergence of power electronics industry, what we have seen is the solar power electronics industry become more flexible to be able to communicate with, to control, and otherwise be connected to, and be the intermediary between a generator like Emrgy's hydro or a wind generator or some other type of generator, and to the ultimate end user, whether that end user is a grid, a national grid, a local grid, or even its own grid, right? Locally, local microgrid. And so at Emrgy, we've been focusing very deeply on technical innovation that allows us not just to play the modernized or an industrialized electrical grid, but also with a number of other types of hybridized systems, whether it's a hydro-powered aquaponic system, or a hydro-powered hydrogen fueling station, or a hydro-powered drone charging station, or even an energy bank where you might see a whole series of home-based batteries that could wirelessly transport power from the water infrastructure to different residences. And so that integration is something that takes the building block, the hydro building block that we've been innovating for many, and in it to be the catalyst for many, many other electrified industries. We're seeing, especially here in the US, a number of organizations advocating to electrify everything, so to speak, and take everything from fuels to electricity. And we're well positioned to be able to utilize the reliability and controllability of water to facilitate that push for electrifying everything.
Yeah, this is fantastic. I mean, electrifying everything is very important. I'm very passionate about that. I'm just thinking, because you don't need to go very high tech, you already have a technology very well established. You have pilot project, you have actual project, and these are like a 250 kilowatt system, right? So it can be scaled up and scaled down as well, right? So if, hypothetically speaking, if you are targeting, I don't know how many thousands or hundreds of thousands diesels are out there, diesel gen sets in all over Pacific, in off-grid areas like in Afghanistan, Pakistan, India, all over Africa, Indonesia. So if the common enemy was diesel gen set, say 100 kilowatt to 250 kilowatt, how far are you from taking that as a mass project, saying, let's get tens of thousands of out there and work with global climate financing groups like Green Climate Fund and others, and take it up big because the technology is very much proven. Hydropower is one of the oldest form, right? So where are we
That's
on
exactly
taking
right.
it? How do
Yeah.
we do that?
Yeah, no, it's a massive but incredibly meaningful undertaking. When you
Mhm,
think about, as you said, the thousands, tens of thousands of gen sets out there, some of which, we may easily find and we know where they
mhm,
are and how they're operating, and others, are perhaps quite old and are getting diesel transported in from very long distances
mhm,
just to
mhm,
be
mhm,
able to operate them. In some cases, it might even be difficult, let's say, uh, to wrap your arms all the way around, right? As exactly how large that is. But what's exciting is that this is the type of project where you can sort of eat that elephant one bite at a time, so to speak.
mhm,
And while we want to eat it in thousands of bites over and over again, and the direct replacement can actually be quite simple, right? The
mhm,
outputs of the diesel genset and the outputs of an Emrgy system can be, in many ways, sort of one for one type of, um, of replacements. It does. There is a geography filtering required. Obviously,
mhm,
we need to ensure that there is a reliable water source nearby, or one that can, be with storage or other types if it's not reliable, because of course the last thing we want to do is take away something that, even though it is dirty energy, if it's reliable and it's something that the village or the community is able to grow, have community development from, we don't want to replace that with something that's intermittent or perhaps at risk of
mhm,
not being reliable. And so I think generally there is the opportunity to be able to do that, something that can be done, let's say, in phases, because
mhm,
it's we're not replacing a lot of small decentralized facilities with one large, right? We're able to do this on a decentralized basis, and meet it where it is. But it does require a series of partnerships, as you mentioned. Maybe it's green funds and financial partners to facilitate. It also will include a whole host of localized partners that know how to do business in the local region, understand the cultural sensitivities, the specific technical requirements. For example, the number of educational facilities or medical facilities that may need to be serviced by one specific area or one genset, so to call it renewable genset. Um,
mhm,
there are many things in which Emrgy, being a US based company with global reach through our partnership with GE Renewable Energy and manufacturing
mhm.
and ability to serve clients all over the world, we expect that local partnerships will be absolutely critical success for that. So it's one of the things that, as I mentioned before, is a massive challenge, but one that is
Mhm.
incredibly meaningful when you look at the impact of taking that diesel offline, not just from let's say saving of tons of carbon emissions, but also the kind of cost that diesel represents. And when you really boil it down to a kilowatt hour versus kilowatt hour cost metric, I think you'll see that water represents an more cost effective and often reliable source of energy compared with those types of systems. So,
Yeah, yeah, you mentioned, and thanks for sharing this detail. I'm sure that vision you're working on and that will come true because water is everywhere. Everyone understands hydropower. So coming to the cost, because you are bringing in 24/7 electricity as opposed to all other form of renewables, especially wind and solar gets a lot of blame for intermittency. So solar, 5 cents a kilowatt hour, maybe plus batteries another. So about 10 cents a kilowatt hour, I think people will be willing to pay right now, maybe for 24/7 and be super competitive. Where are you in terms of pricing cent per kilowatt hour?
Yeah.
Levelized.
Yes, happy to chat about that. As you know, the levelized cost of electricity is the common benchmark across all different types of renewable and non-renewable systems. And at Emrgy, we focus opportunities in which the levelized cost of electricity can be as low as 2 cents. And we try to focus on
Seriously?
projects that can be between 2 and 6 cents a kilowatt hour. Here's how we get there. Let me go into detail before you get too shocked, right? So
No, 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 I'm excited.
As many of you probably know who are listening to this podcast, LCOE is calculated by taking the total installed upfront cost. You add in the ongoing maintenance costs or feedstock costs over the course of a system's lifetime. And you calculate that, you divide that by the number of kilowatt hours that will be produced by the system over its life, which is determined by its capacity factor. So when you look at a system like Emrgy's, our installed upfront capital cost, can be somewhere in between around $1,500 a kilowatt up to around 4,000 a kilowatt. And that really, many of those costs are site specific and based on location and things like that. But the beauty of a machine like Emrgy's is that the machine itself has a rather fixed cost, right? It has turbine blades, it has shafts, it has gearbox, it has a generator. It has a relatively fixed cost in terms of its absolute manufacturing cost. However, unlike a solar power, which is the power rating of that is based on the square footage, right? How many square feet or square meters of panel do you have? With water, you have two dimensions. You have one is what is the swept area, what is the square meters of the turbine, but also what is the velocity, what's the force, what's the speed of the water going through the turbine. And because you have those two variables, that one machine that costs within 10% of the same, whether, no matter what operating envelope you're in, can produce as little as, say, 5 kilowatts on the very, very low end, or up to 22 kilowatts on the same drive line. And so essentially what you end up seeing is that for those low power applications, slow flows, shallow flows, perhaps that, upfront installed cost is a bit higher per kilowatt because the same machine has less power. On the other hand, we see a number of applications. In fact, we're preparing for deployment in Laos right now. So in your region of the world that will have deeper water, faster water that's actually running so much of the time that they can't control the water to shut it off for us, even for one day. It's running 24/7, 365. And so when you see an opportunity like that, and many of you may have ideas in your head of places you've seen that have water that flows year round. Maybe it's not the same rate year round. Maybe you have a wet season and a dry season, but water you see that is present year round. Those are the opportunities where you can see not only very low installed upfront cost because you have a force and a quantity of water that's moving constantly, but you also have a capacity factor that drives the system to be generating its rated capacity a majority of the time, if not all the time. And so when you look at an installed cost, let's say, let's take our median cost of around $2,000 a kilowatt. You factor in the ongoing maintenance costs, which are absolutely there. This is not a system like solar where you can put out and not touch again. This is electromechanical machinery, so it does require maintenance, annual maintenance, and then an overhaul every 15 years. Then when you factor in all of that maintenance activity, which is, on the other hand, job creating and, enabling of really embracing a local system, you end up seeing, an all-in cost that is higher than, let's say, solar. So as a comparison, definitely higher on the upfront cost than solar. But when you compare that with the capacity factors we're seeing, that project in Laos that is running 365 days a year, or perhaps other regions where you may see 70, 80, 85% of the time the power is meeting or exceeding its rated power, then those are opportunities where you can see LCOEs, sub 3 cents a kilowatt hour, which is really, really exciting. Now, of course, that doesn't happen everywhere. And the challenge with water is that water truly is hyper local. Really only the local parties, local communities really know how the water either has been operating, or even, it's much harder to predict future flows in water than it is perhaps, to predict future sunshine, or to predict, future, availability of other feedstocks. But, our job at Emrgy is to work with local partners and uncover those opportunities within communities that can have really reliable and therefore very valuable water flows for power generation.
Well, the last part, I don't agree. We have been, I studied hydropower engineering. So yeah, we have been training rivers, moving things, building dams. So for your 250 kilowatt, you don't need much water. So you can actually, if there is water out there, you can redirect to make sure it flows right through your channel. All you need is a bobcat or one of those machines, and someone who can play with those. Yeah. But
I love talking with you, because I get refreshed on the ingenuity of creating the future that you want to see, right? Here in the US, these are typically seen as retrofit projects. We have water infrastructure. We at Emrgy retrofit that water infrastructure with equipment. And there's, I would say, perhaps slightly less ingenuity of, redirecting of water, changing of things, and it's very highly regulated here to be able to do that. But it's always refreshing to speak with you, because I'm reminded that the world is a much bigger place than what we see here, with high regulation around water in the US, and the ability to develop projects, not just retrofit, but be able to have the water and the feedstock that we need to have the type of power generation miles and cost is something that is, of course, the opportunity here.
Yeah, the reason I mentioned this, about 10 years back, we went to a family property. One of our colleagues, Sam Tumiwa, his father has passed away. He used to run a large school sort of thing. It's a very large property outside Jakarta. So a lot of water stream coming in. And I was actually calculating what's the speed and how much water flow. And we looked at putting a micro-hydro and calculation, and then it's a lot of extra work. But had there been a company like what you are saying, that you just come in and plonk it in, that would be so much easier, right? So in those circumstances, because he owned the whole area and 2-3 streams coming from the same sort of mountains, just putting them together and just a bit of manipulating that water flow. It's not a huge dam or anything, just a little bit amount of water and a bit of weir to turn them around. So those sort of situations, because 250 kilowatt doesn't need so much of water, right? And you can, I believe, also make things smaller in future, right? If there is sufficient number of interest, right?
Yes, absolutely. We're building ultimately what we're looking to do is build the solar panel equivalent in water, right? We want something that is highly modular, that's highly scalable, that has standard sizes from very small to potentially much, much larger, and be able to, as you said, just plunk it in. The construction elimination aspect of what we're doing is one of the most important. And when we talk about, patent work or hardware IP, things like that, we don't focus at Emrgy on the shape of the blade or squeaking 1% extra efficiency out of the water, because, really where, as we talked about before, this is the most ancient form of renewable energy. And, that is an area that is very, very, very well known. Now, we do utilize hydrodynamic principles, and some of the most advanced hydrodynamic experts in the field of, power generation using fluids. But what we focus on is really these other elements, like we talked about, no construction as the primary places where we innovate, because that the ability, when we take out construction, the ability to install in so many more places expands, immediately. And, as I talked a bit about the US market, especially with these being retrofits, there is a lot of, let's say, there's a lot of regulation and a lot of permitting required any you construct in a watershed environment or even in water infrastructure. And so to remove that construction element, to have something that simply sits on the floor of the channel, and channel maintenance, if there is a flood, if there is any kind of event, you can simply pull it right back out of the channel, is something that is a very, very valuable trait when it comes to power generation.
Yeah. I mean, let's. You give me this is something I've been. I thought about it 15 years ago. I could not do it because of many other constraints. Traditionally, you find a site, then you find a bunch of engineers to come in, you do a feasibility study. Today with the drones, maybe much easier to get the topography, and then you build a dam and you custom design, as you made the hydro, right? I had the idea of doing something in Indonesia many years ago, was, okay, let's decide on that we are going to build 250 kilowatt hydro. So you do the bidding and everything separately, and you decide this is how the control station looks like, this is how the channel looks like. And then you basically cut and make the site fit to the product. And exactly as you mentioned, that yes, there may be not enough water in a particular case, or maybe too much water, but the turbine may not be running at optimal, because that can be easily offset. Because of this large procurement, we may be able to get 30 or 40% cheaper costs than the normal capital cost of it. So that will compensate for the inefficiencies. And then you can, as the government level, the idea was that you go and invite everyone saying, listen, if you have a site which is sort of 70 to 150 kilowatt range, please come on, and we are going to plonk in 100 kilowatt system. And then you can do a single go. And because the community, some of the communities doesn't have money, we talked to a bank at that time. It was a Asian Development Bank, that we would have done it with a local bank who will turn this into an annuity, so that the local government is not going to fork out the $2,000 a kilowatt hour that you mentioned in the beginning, but they are going to have a sort of deal whereby the bank will be almost like an ESCO, so gradually recovering the revenue over a 15-year period. And after that period, the ownership goes back to the local community. Something like that. Do you think that makes sense? Because you are way much ahead. At the time, I didn't have a company who could do it.
Well, you're absolutely, in my view, clear 15 years ahead of your time, perhaps. But
yeah, I get that blame a lot. Yeah.
when you look back over a parallel history over the last 15 years, you can see so many things that show why that's successful. So let's look at solar power, for example. There's a few different types of solar power. There's obviously ground mount and different types of mounting. They're all, generally the lower efficiency, the 200 to 400 watt panel configurations. On the other hand, there is concentrated solar, right? That can achieve, that is more customized. It is, can achieve much higher power density, may have much higher efficiency, and does require a lot more soft costs, a lot more development costs, a lot more engineering costs, all of that to have one project. And if you look at, the growth rates, the success rates, the industry growth, what solar has taught us over the last 15 years is that the low cost, the standardization, the ability to sacrifice efficiency, just like you said, even if it's overproducing or underproducing, if you're saving 40% on cost, that gets projects into operation. You see that, we have one CSP project in the US that is not, we're not growing in more of those. And so, comparatively speaking, I think, as you mentioned, having an archetype project that says, okay, here is the size of project that makes sense for these size communities, whether it's one or two, but it's standardized, and we're able to provide. And actually, Emrgy, we already do this. We have a standard set of site requirements. We like to have a minimum channel size of at least 6 feet, or let's say 2 meters. We like to have a 2-meter channel size at a minimum. We like to have at least 50 centimeters of water depth. That is nominal, throughout the channel. We provide a specified gradient range. And essentially what we do, similar to what you did, is we look at, okay, can we standardize these 50 sites or these 150 sites to where you have within a range, not all systems are going to be performing at their peak efficiency. Some might be what we call over submerged. They might be let's say a 2-meter tall turbine that's in a 4-meter deep channel. So maybe you're not fully taking advantage of the cross-sectional area of the water, but you're ultimately operating at your peak, right? The peak of the system, right? Because you've got more power going through the system than it's actually generating. Or on the other hand, maybe you have other sites that are under submerged and maybe are generating a bit less, but generally by standardizing the system, standardizing the arrays, you ultimately have a substantial cost reduction through that ultimately gets the project moving, which is what we need, and look out at the types of, whether it's carbon neutrality goals, whether it's electrification goals, what we have solutions, we need to be implementing them. And so that's where we, of course, are fully aligned with that strategy, that having a standard archetype that can be replicated is something we've seen works very well in other industries and has led to exponential growth of renewables by standardization. And so we see that water has lagged in keeping pace with that. Hydro still tends to be so custom, as you said, and hydro engineering tends to focus on efficiency and focus on bespoke systems rather than scale of deployments or number of opportunities to develop projects. And as a result, the hydro industry has been quite a bit behind in the renewables and energy transition globally, and we're hoping to change that.
Yes. I mean, fantastic. So, but there is one other thing too, no? I mean, when you combine, it's not only get procurement discount. That was my other argument. If you have done the procurement already, then you go to a mayor or the government, then you can say, hey, as soon as you agree, the thing can be installed within 3 months, as opposed to taking 3 years to go corporate procurement and design and feasibility study. So that also reduces your LCOE, or whatever you call the levelized cost, because the time it takes, right? Like a solar, you can make a decision and can have it there within 3 months. That makes a
Yeah,
huge difference.
huge difference.
Now,
Speed is everything.
yeah, I mean, last time we discussed, and you had a lot of encouraging comments about young entrepreneurs, especially women. Now, I'm just thinking, if someone out there listening and think, oh, okay, my community can absorb 50, and I know so and so as a bank, what can they do? What should they do to make a project like this feasible, where they can find you? What you need from
Yeah,
them?
please reach out directly to me. We've got, of course, local partners as well that can work directly on some of the permitting or other feasibility questions that you may have. But I think you'll find that our team is incredibly excited about the global opportunity for this, and where there is an opportunity to deliver real value, we want to be right there doing it. And so my contact details, I hope, will be posted, or I can provide them now for listeners of the podcast. But we're a small and nimble and growing team that is, as you may know, based in Atlanta, Georgia, but has global reach and global ability to deliver. And so we would be honored at the opportunity to grow these numbers of 50 to 250, or really up to, we're looking at projects really up to 5 megawatts each right now, especially with some of the more let's say the lengthier canal systems that run throughout different agricultural areas. And would love also to partner on hybrid systems, as we talked about earlier. If you're an entrepreneur developing electric bicycles, or developing other electrified systems, we'd love to talk to you about a hybrid solution that can help make sure that your systems are always have the electricity reserves that are needed to power your tech. So we're in a position now that we're not only we have proven, as you stated, the hydrodynamic value of the system. We've proven cost metrics that are needed. We've proven that we can deliver across country borders, and really now we'd love to prove that we can do this in a way that scales rapidly and scales effectively to deliver value where it's needed most.
I mean, what I will like to see exactly as you explained to the next stage. If you Google today, and you will find hundreds, maybe thousands of YouTube posts of people talking about solar power. They absolutely have no idea what solar power does, but they are so well informed, technically to the point. They will, listening to those videos, you will be able to go and buy a solar panel and get your lights on. So I think your technology need to come that stage that people saying, okay, go to the local hardware shop, buy your 50 kilowatt hour, not 50, maybe 5 kilowatt hour system. And this is how you plunk it in on your backyard.
And that's what we want to enable. Really, this energy transition should be democratized. It should be in each of our hands, as we all have a part in this energy transition. And it's really a shame. That's why I started this business, was that I recognized what a shame it was that water wasn't innovating in the same vein that solar and wind were innovating. And yes, there's a lot of micro hydro designs out there and different systems out there, but they're almost always bespoke, and they're almost always requiring of a lengthy regulatory financing and construction process. And to be able to boil that down into something that is very simple, that is very scalable, and that can be cost effective, then we want to be on the leading edge of doing that. But really, we want to empower. We want to empower local communities to be able to also develop access and grow this locally as well. And so we are putting together not just the ability for delivery of these types of systems over the world with global supply chain reach, but also the ability to install, interconnect. One of the most exciting things that we've done this year, when I mentioned that we installed a system in New Zealand, keep in mind that this is in a global pandemic with one of the most isolated lockdown countries on the planet. And so not one of our team members, whether they're on the product side, the sales side, the deployment side, none of our team members have ever stepped foot in the country. And we have a really exciting, high performing system feeding electricity into the national grid. And so the ability to confidently do this in many different locations, regardless of travel capabilities or restrictions, and the other types of challenges, unforeseen challenges that have come up in this pandemic, it gives us a lot of excitement and confidence about being able to empower communities to develop these directly, and we want to be that catalyst.
Yes, I completely agree. And I like what you said at the beginning, future of electricity is distributed. I think that's very important, and seeing that you're delivering the vision, this is fantastic. Anything else you want to comment on that I could have asked or chatted about today?
No, I mean, the last thing I'll mention is one other area of innovation that we're focusing on here at Emrgy. We've talked a bit about the water innovation of being able to eliminate construction. We talked about the grid innovation where we're utilizing solar power inverters or the type of equipment that can allow us to connect in anywhere or to anything. The last area of innovation that we are spending a lot of time on and love feedback from the listeners is around financial innovation. As we've talked about on this call, for some of these large projects, bringing the green funds or other types of banks in to help enable a rapid scale is absolutely reasonable. However, on the localized scale or small, one of the things we're focusing a lot on is eliminating capital as a barrier to being able to access these systems. We don't want the capital cost or the upfront cost of the system to be the reason why this can't scale. Even though it is in some ways very comparable to solar or others, there's a justice here, right? Environmental justice, where the people who may need these types of systems the most access them for one reason or another. And so at Emrgy, we're developing a program around where if you know of a village or a community, as you mentioned before, that could host one of these, perhaps not purchase it or invest in it, but host it, we want to work with you. And we can bring the financial innovation to be able to allow you to host the system, realize the electrons, but otherwise, monetize the system in creative ways that we obviously it varies where you are, how to monetize the system in such a way that it's a win-win for everyone. But it is something that we're spending a good bit of our resources developing, is how we can financially innovate this system so that anywhere on Earth where there is a site that can host and for power generation for distributed hydro, that we're able to develop that site, and that capital shouldn't be a barrier to that. So please don't hesitate to reach out to me if you have on where this could be hosted, or technologies that could hybridize together with it. And we're excited about what 2022 will bring for all of us here in the energy transition.
Thank you very much. I'm sure people will connect, and we'll share your details here. Anyway, you want to share the details of the Emrgy website? Maybe now you can.
Sure. So please visit our website. We'd love to hear from you. Our website is www.emrgy. It's EMRGY.com. Emrgy is an engineering term defined as the sum of different types of energy that come together to make a product or service. At Emrgy, we drop that middle E. So it's just emrgy.com. And you can find us there. And I'd love to hear from you.
Thank you, Emily. Thank you very much. Lovely
Thank you
to
so
catch
much.
up.
It's always an honor to speak with you. And I really appreciate the opportunity to connect again today.
Thank you. Okay.
Thank you for joining us this week. If you haven't done so yet, subscribe to our show. Also, leave your comments and review if you enjoyed today's episode. Follow me on LinkedIn and Twitter at shasni for updates. That's SHASNIE. Once again, this has been Energypreneurs, connecting you to the innovative opportunities in solar power, batteries, and electric vehicles. Stay tuned.